Well, it must not have been recording. Okay, pull apart. We'll get started. So I'm going to let it run from pretty much no parts on there so we can see the hopper operation. We can see the hopper is dropping parts in based on the camera that's in position. That's this camera right over here. So if this camera doesn't see parts in this area, the hopper will kick on and it'll run until it sees parts so that it replenishes gradually. That way we don't get an overrun of parts. It actually it sorts much better and runs much more reliably if the table is not overloaded. If the table does get overloaded, you can get jams in the back. So you can see here where the hopper was dumped on, and we elevated the hopper 4 inches off the other feeder so that the parts have a chance to break up. Now as the parts go up the track, you can see the first spot where they run into the blue area. That blue area is brushed that's biased to the right direction. Oh, back there, like the first section. Yeah, in that section, that brush is biased, so the parts that are tab side up see more friction, and they push over to the right. Parts that are tab side down, they'll keep moving all right to the top, and then they'll come around. Parts that are upside down, you can see as they move over into the other area, they'll go into that area that will actually twist them. So the parts will be twisted and dropped in the right direction. So once they go around, you can see them coming around the loop at the top, and they'll come down the track. And those parts coming down that track are upside down, so they're going to flip in that twist track. So the part is picked up over here, and is indexed over to this area, this nest here, and that nest has a sensor on it that tells your robot that the part is there to pick. So your robot just has to pick that part. Once it removes the part, the feeder just starts up on its own and presents a new part immediately, or when that next part gets into the nest. And you can see a typical cycle time is somewhere around 5 to 10 seconds, so we should hit that 3 parts a minute very easily. If the feeder has good parts in it without a lot of bent parts are an issue. They might not feed in properly, or might fall off a little bit as it goes to the end of the track or cause a jam. But in all those cases, the feeder will just fault out and give you a signal that it's jammed. The part needs to be cleared, then restarted. But if the parts are not bent, if they're straight, we see very, very little issue with the indexing. The parts get to where they need to go. So in this area, in the camera area, you want to point to that, Mike? In that camera area, that camera is looking in a very small area to see that there's one part, or if there's 2 parts, that they're properly separated. If they're too close together, the camera will turn on the air blow off and blow off the part behind it. If the parts are, if there's only one part, it goes through, no problem. But if there's a clump like you see right now, all those parts will be ejected. And that way, parts that are intertwined or stuck together, we blow off, and then new parts come up. And you can see where the camera separated the parts, even though they were close together. Now that setting is done right from the PC. It's a very simple setup. I'll review that in the instructional video. Now the sensor in front, that sensor looks for a part to reach that threshold. When a part hits that threshold, it turns the blow off on also, same as when the camera does, and it keeps any parts that are following from coming up to the nest so we don't get a double part. At that time, the feeder stays on and vibrates, and the air blast blasts the part into the nest until the nest makes that front switch. When that switch sees the parts for 0.2 of a second, it stops the feeder, it indexes the part forward and puts it in position to pick up. So if we have a part that's bent and can't make that sensor, can't fit in that nest, it's going to sit there, and then eventually after a preset amount of time will fault out, and again it'll give you a signal jammed, and you clear the part and restart it. Go ahead, Mike. The small air line in the front turns on when the air blast kicks on. That's what keeps the part forward, pushes it forward and gets it underneath that switch. It gives us a positive insert into the entry nest. And you can see as it runs how the hopper maintains the proper cable level. The number of parts you see on the table right now is the ideal amount. It gives us a nice spread of the parts, but it still gives you plenty of parts on the table, so that cycle time is very easy to meet. So the machine runs all by itself. If you don't pull a part out, it's going to sit and wait. So the minute you do pull a part, it's ready to go and it'll start to index on its own, as long as it's an auto cycle. There's also a manual mode where you can run each feeder separately. You can see all the sensors, whether they're on or off. Makes it easy to set up the speeds. But since this is only running one style part, once you set those speeds, everything is going to work and it's going to stay like it is. Didn't need any operator adjustment. So I'm going to walk to the control box for a second and review some of that. And Mike will keep the machine running so we can see it. So there's the air regulator. We keep that up as high as it goes. We also have another air regulator right over here. This regulator controls the escapement cylinder, so we keep that pressure very low. You can see we're right around 20 psi now, and that makes it so that the parts don't get squashed, and even if someone puts their finger in there, it can't do any damage. So I'll zoom in on the escapement here to get a better look, and it'll give you an idea how the part gets in there. And you can see the sensor right over here. This is a fiber optic sensor that detects the part. This is an inductive proximity sensor that detects when the part is in place, and we'll watch it go in the nest. You can see when that sensor makes, that's when the part indexes forward. And there's the air line that blows the part forward. This you can see it in the left. And this is the camera, the inspection camera for the track to make sure we don't have double parts. You can see it's got a wide field of view, but it's down pretty low. These brush strips are going in that direction. This brush strip is biased in that direction to get parts to come off. This is another sorting area. This sorting area makes it so that if you can see if a part is this way, now the part moves. So these are tapped down the way we want them, so they stay going forward because the bias doesn't affect the tap. If they're the other way around, and I'll put this like this, you can see this part will go right off there. So any part that's upside down automatically goes into the exit track, and you can see as they go forward how they'll flip and fall down the other way. So when they come back around, they're tabbed down the way we want them. So as the machine runs, your percentage of parts are tabbed down increased dramatically. So once you get in cycle, you get a high percentage of parts that are the correct way. This is the area, if they're upside down, you can see it. See how that moves sideways? So that's going to take those upside down parts, take them down that track, so they'll go down that track and flip. Now this turnaround area over here, if you overload the table, you could get jammed. And we restricted this area, we narrowed it down a bit so that even if you have a lot of parts here, you don't get a lot of parts here. It still filters them out. And eventually they'll clear out. This is a hopper area. It can obviously hold hundreds of parts. We advise keeping the number of layers down pretty low, but if I were to take and put all these parts up front, like that, and on top of each other, and you'll see next time the hopper kicks on, even with all those parts, they're going to fall and they're going to spread themselves out. So even if they were entangled and on top of each other, parts out so the hopper will run. So you'll see when the hopper kicks on. The hopper will only turn on when the rest of the system is running, so that we don't dump parts in an area and get them all on top of each other. You see where the hopper just takes on? So when they drop, you get separation. When they go back around to the top, even a large clump like that will resolve itself because they'll start to spread out. And when they first dump it, if it's a large clump, it might take one time around to get them spread, but they'll be spread out in no time at all. So I'm going to go over to the control panel and just give a brief rundown. We'll get more involved in the instructional videos, but this is the PC. It's just a Windows PC. It's our own program that we developed for this. So this PC is an HMI that lets us set the frequency and the power of the hoppers, the recirc area, and the exit track. So I could change the frequency and that'll change the response to the feeder. Now these particular frequencies of power work well for these feeders in this setting, so they're pretty well set. There's nothing to do with it once they're set. Right here it tells you it's connected. That connection is to a Controlino. It's an Arduino-based PLC, and that PLC does the pulsing for our feeders. So whatever we enter here, that passes that information on to the Controlino PLC that does the pulsing. Then we have, so I'll bring up the hopper camera. If you look at the vision, you can see right now, that's the vision area of the camera. That's where it's pointed. And in that, you have your camera settings, which allows you to set your exposure for different lighting. Then you have your baseline, and this is your baseline image right now. So the baseline image is the image that you take with no parts on there. So you would just retake the image, and that'll save the current image. Then, after you're done with that, you go to part detection. And part detection sees anything that was not in your baseline image. And you can adjust that threshold. See where I just cut it down? Or make it so all you're doing is adjusting the contrast threshold. So once you do that, that's all set. Then you go over to your table level refill, and you can see right over here, when it's green, it means that there's plenty of parts on the table. When it goes to red, it means that there are less. And you can change that on the fly. You can hit trigger point for automatic, and that automatically sets. So if it sees one part, that's the trigger point. Anything more than that won't run. So I'm going to increase it a little bit, so that if we follow, like right now, there's that many parts. Anything less than that is going to trigger the hopper to turn on. And that's all there is to it. And you can adjust this on the fly. If you're getting too many parts, you can cut it down. If you're not getting enough, you can raise it up. Like if I go down to here, it's going to shut the hopper off. So you can see where we filled quite a few parts because I had it set low. So that's that camera. Then the other camera is your exit track camera. And that window pops that up, and you can see the area. So as the parts go by, you'll see. So let's look at those parts, and you can see when there's two parts, the trigger point goes to green when there's one part. If there's multiple parts, you'll see it trigger red. When it goes to red, that's where the air blow-off is going to kick on. Wait till you get a few parts and you can see it go red. So the parts are separated enough so we're okay. But if we take it down, you can see the red trigger and now it's blowing them off. Now, just like the other camera, this is adjustable. So you can make it, fine-tune it to just one part, separate them a little better, or be a little bit more relaxed with it. Same way, this one, you take a baseline image with no parts, then you look at your part detection, that sets your threshold. You can see when a part moves in, that wasn't in there, the camera picks it up. And then, of course, your part level, which you can do the same thing. You move it up and down while it's running. They find the perfect spot where it catches more than one part. So that's all there is to setting up the camera. And then when you're complete, all you have to do is you hit that and you enter the code. And that locks it. That makes it so nothing on the screen is adjustable now by an operator. So only authorized personnel can make the change. And again, if you go to change something, you have to put it in that mode, enter the code, hit enter, and then it unlocks. You can see nothing's locked. So that's all there is to that. Now, you can save 5 different programs if you were running multiple parts that need different setups, different camera settings, things like that. You can change program 2, 3, 4, and 5, and you can save them. But in this system, you're just going to need the one program. So then we have the PLC HMI, and this is fairly straightforward. You have you can select manual, and you go to manual mode. And in manual mode, you can run. No, good. In manual mode, you can run each feeder. And you can kick the blow off on and off. You can advance the exit cylinder. It also tells you if the sensor sees a part or not. If it sees a part ready at the escapement. It didn't see a part at the exit, and that's your track sensor. And so that's all there is to that. And then you have your main screen and to run. So currently you're in manual mode. If you want to run, if you're in manual, you can go to the manual ops screen. If you go to auto, automatically puts it in auto mode. That's all it takes to run it. So let me just pop this open. The PLC is a ProFace, and you can see the I/O on it. It's a nice little modular unit, very useful for this size machine. There's the model number if you want to look it up. I also sent it to you in an email. And I'll just take a look at the control cabinet, and we should be all set. So this is the interface cabinet so we bring all of our sensors into that so it's easy to get to. And then the main cabinet, which is right here. So we have our 4 solid-state relays that are pulsed by our Controlino PLC that communicates through USB to our Windows PC. That acts as the program for the camera and also the HMI for the Controlino. We have our 48 volt power supply. That power supply supplies all the 48 volt DC to our feeders. It's a 10 amp supply. Our feeders in this system are probably drawing somewhere around 3 amps when they're fully on. So they're very low power feeders, but they have a lot of power to move parts around. Over on the side, you can see these are just diodes off of each of the feeder to suppress the back EMF when the field collapses so we don't get noise back into our system. We have our 24 volt supply and our power in, which is nothing more than just a 110 volt cord, standard outlet that unplugs. Over on the side, you can see the 110 volt outlet with the power supply for the PC that goes up into the control cabinet. So that's the overview of the machine. That's what it looks like. So let me get a good shot here. Yeah, I think we've pretty much covered the majority of it. Of course, like I said, the instructional video will be more detailed, but we're in pretty good shape and the running is going well. So look it over, let me know what you think.